You say go and I'll go. I mean, not like go, I'll go with the slides. Just. Yeah, that was the joke. Yeah. All right, excellent. Well, appreciate everyone coming this evening. I mean, I realize it's standing room only, and I thank you for that. I mean, I'm honored. I truly am. I realize and recognize that it's really just because you're waiting on your table at the Hard Rock or wherever on 4th Street. But, hey, I appreciate you being here. I really do. Hopefully this will be something that is interesting to you, informational. And so this is my talk. This is Shackles, Shims, and Shivs, trying to have a better understanding of locks to bypass them. So I am Mirovengi. I'm a member of the Fraternal Order of Lock Sport, better known as Fools. We put on the organization, or we put on the Lockpick Village here at DerbyCon and have since the beginning. We are honored to do so. We are thankful to do so because we get the opportunity to come every year and hang out with everyone and also hang out with other members of the community. And DerbyCon is always a good time. You know, the only real relevant credential that I think I have to my name is that I spend a lot of time with local law enforcement, as every good lock sport enthusiast should, to help promote the sport, but then also you can help teach law enforcement, and then they will turn around and use those skills themselves. So the standard disclaimers apply. I'm not responsible for anything you do with with this information. I speak as an individual and not on behalf of my employer or any organization. Also, pictures and videos used in the presentation are used without permission. However, I do try and give attribution where appropriate. So, why this talk? Right, physical security is important. We often recognize that it's important. We often talk about why we need physical security, but there always seems to be this kind of binary thinking that we only look at either picking the lock or just kicking down the door. Right? I mean, maybe it's just because picking locks is the sexy thing to do, but we would much rather sit there and spend 10 minutes like raking on a lock because we couldn't single pin pick it, when we probably could have bypassed it in the first 5 seconds. And we'll talk more specifically about what bypassing means, but a good example is the GIF that I have included in this slide. So to really talk about bypass mechanisms, we're not talking about the lock itself, and we're not really talking about the door itself. We're talking about the retention mechanism, that middle ground that's really what is actually holding the door in place. What's actually keeping the door closed, the window closed, the barrier, whatever that may be in whatever form that may be. So some standard retention mechanisms. You have latches, you have deadbolts, which we're all familiar with. We have wedges, which we've all used, but probably has a more technical name. I use wedge for a specific reason, which we'll get into in a bit. There are ball bearings, which you typically see in padlocks. You have catches, another form of a latch, typically like bars and chains. So for the most part, if everyone's staying in a hotel in the nearby vicinity, you probably have one of these in your room. Then you also have more industrial mechanisms, like your crash bars, like you see on the doors here in the room. Electric strike mechanisms, and then electromagnetic mechanisms, which depending on your industry and depending on what you do, your building probably incorporates some form of an electromagnetic retention mechanism. So since we're at a security conference, we have to use the standard triangle of security, functionality, usability. All right, because as you kind of see, and as you start looking at locks, right, this triangle plays out and plays into a lot of organizations' decisions on their retention mechanisms, right? So what do we mean by that? So let's take, for instance, deadbolts, right? Deadbolts are high security, right? Because it's just basically, that cylinder, that piece of metal that traverses through, from the door into the door jamb, and that's the retention mechanism. But there's nothing fancy about it, right? So it has low usability, it has low functionality. You have to turn the key to open it. You have to turn the key to lock it, right? And depending on the deadbolt, it's keyed on both sides, right? So you can't just be inside and lock it, you have to have a key and lock it. So we're talking low usability, low functionality. And there's not really good consistent ways to bypass these types of locks, right? There are some mechanisms. I tried desperately to find pictures. There was a Chinese made tool, I think referred to as a cat's eye, that basically you pop out a peephole, and then you can pass this tool through a peephole to then actually reach down to have enough room to grab the back of the deadbolt, right? But again, it was kind of specific to doors that had peepholes, and then you're also removing a peephole, which, again, depending on the installation, may be kind of a destructive mechanism. I could only find references to it. I remember talking about it with DOSman and some other fools. Unfortunately, I couldn't find any pictures of it. So you have deadbolts. People use deadbolts, but in some cases you do want more usability out of your deadbolts, right? You don't want to have to, unlock it and lock it each time. So it was very common in hotel rooms for a while that you would have an added deadbolt to your door that once inside your room you could activate the deadbolt, and even if you keyed on the outside, you couldn't open it. You couldn't open the door, right? You had to, from the inside, open the door handle. Well, a very easy bypass tool then that came out of that is the under door tool. And so here's a video we actually took of DOSman in the Village yesterday demonstrating the under door tool, which is just quite simply a piece of metal and a string that you pass under the door. You rotate it up so that you can grab at the handle, and then once you hook it on the handle, between holding the cord down and manipulating the metal piece, you can then actually manipulate the inside handle. Now, in this case, obviously, that wasn't a deadbolt, right? And for the most part, I was actually kind of surprised. It seems like the hotel doors in this, or I'm sorry, the doors in this hotel don't seem to have that deadbolt mechanism anymore. Like they still have the latches, but so maybe that functionality is going away. Maybe that deadbolt mechanism is going away. But obviously, the under door tool isn't limited to just deadbolts. And you'll kind of see that the under door tool becomes really handy if you don't have one. I recommend either getting one or making one, because we'll talk about more, but they become really handy tools to have around. So let's moving on from deadbolt. We'll increase in functionality, and we get to the wedge. And why I call it a wedge, right, is I have an engineering background. The wedge, or specifically triangles, are very strong, very unique shapes to use in engineering. And the same is true for doors. So when you have a wedge, right, so in this case we have, just a triangle on the screen. When you apply a force down along the incline, that will move the wedge, right? So normally if you have like a square and you have to push the square horizontally to move it horizontally. Well, a wedge, you can push it vertically and it'll move horizontally. And so that's why the wedge became very popular to be used indoors, because now all of a sudden you can have the wedge spring loaded, and as the door closes and it hits on the door jamb, right, the movement of the door will drive the wedge back into the door itself, and then it'll actually close. Once it gets closed, then the spring pushes the wedge back out, and then your retention mechanism then becomes the broadside, the flat side of the wedge. And so it effectively becomes a one-way gate, right? Because you can go through it, but you can't always come back, right? So the wedge becomes a very useful mechanism, because we can increase functionality. We don't have to decrease the securability of it that much. But of course, as anyone who has been 15 to 18 and had some sort of a credit card or something before, you know that wedges have flaws, right? So this is a standard. This is, just one of probably countless YouTube videos out there of this gentleman. I think either has a Dick's Sporting Goods card or a Bass Pro Shops card, and he's working it around the door jamb to get to the wedge. He drives the card across the wedge, which moves the wedge back into the door, such that then the door opens, right? So pretty standard technique. If you just one more time, just to make sure, because this becomes a very important concept. Because in the simplest form, This attack becomes useful almost anywhere, because pretty much every door has a wedge, and in a lot of places, the wedge becomes the only retention mechanism that they rely on. Now, there's some industrial areas where obviously that's untrue, but it's still, the wedge is a very, very useful tool. So places where this doesn't exactly work out, places like my building, where the door and the door frame, because of the contract going to the lowest bidder, you don't exactly have the greatest tolerances in the world. Yes, that's a tape measure. Yes, that's almost half an inch, right? We're like a 1/16 of an inch or an 1/8 of an inch short of being half an inch. It's almost big enough that I can reach my finger in and manipulate that wedge to then actually drive it back and then open that door. Fortunately, this door is not my server room. Unfortunately, it's the mechanical closet. So it's where all the HVAC equipment is for the entire building. So obviously, that's not good. The wedge is not limited to doors. You also see the wedge in padlocks, especially a lot of your cheaper padlocks. Now, this is a clip from a Bosnian Bill video. He's a very renowned individual on YouTube who does a lot of lock-picking lock sports stuff. He has some fantastic videos, and this is him demonstrating shimming on a wedge-oriented padlock. Specifically, it's one of the clear ones. And you take the shim, you wrap it around the shackle, and then you just slowly work the shim down so that you drive the wedge back. And then now the shackle is free to move. Now, with this padlock in particular, and I cut the clip short, you do have to shim the other side of the shackle, but once you do so, then the shackle opens, right? So if you watch the whole video, you see you shim both sides of the shackle, because as you can see there on the screen, there's shackles. The wedge is on both sides. Drive it in, and then the shackle opens. So security, tit for tat, right? Red versus blue. Where a lot of padlock companies have gone is basically as you pay more for a padlock and it increases in security, then they have ball bearings as a retention mechanism, and master lock, even on certain locks, they have this custom retention mechanism, and that's the red part there, such that it's shim proof or anti-shim, because basically it just has the notch. It has the notch on the left hand side above the curve to try and really just catch the shim as it gets in, and so that you can't work around that. But the ball bearings are very effective as a retention mechanism. But again, depending on the tolerances, depending on how it's made, you may still be able to get a shim and work a shim around the ball bearing, right? We definitely had, I've definitely seen some rather cheap ball bearing locks that, I mean, you could shake it hard enough and you could open the shackles just because the tolerances were just so terrible in that. So moving on from padlocks, going back to the catches. Yeah, no, go ahead. Going back to the catches, like in the hotel room, you have bar mechanisms that will prevent the door from opening fully, right? And these are more kind of a middle gap security mechanism. But we have these, but you can, and I'll play it again. You can have these tools that once you actually get the door open and you hit on the catch, well, if you can leave something in there, in the door as you're closing the door, well, that will push the bar out of the way, and then you can turn around and open it again. Right? So again, we're looking at playing with the tolerances, opening up spaces so that we can get, so that you can get tools in there and then manipulate the retention mechanism. Chains have similar problems, have the same problem. In this case, they've tied a rubber band to the end of the chain, and basically he's going to get the chain, attach it to the door handle, and as you close the door, the chain slides away, and then it hits its release point, and then the lock opens, right? The chain opens, as you see right there. So understanding the mechanism, right? Understanding how it's actually retaining it, or retaining the door, can then help you understand how to bypass it. Right, and that's ultimately what we're driving at here. So now on to some more industrial mechanisms. like crash bars, right? Again, we have crash bars in the room. Crash bars come in all sorts of shapes and sizes, but typically rely on the wedge. The only issue is where the wedge is located. So in this room, the crash bars, the wedge is located with the crash bar. This is a picture from the lockpick village where the wedge is actually at the top. And so it's kind of interesting with the wedge solely at the top, right? There's nothing holding the door at the bottom. So you can like pull the door out a little bit, and now you've got some room to play with to where, I don't know, maybe you can get a shove-it tool or, some sort of like metal strip in, work it all the way up to the top, and then you can try and manipulate the wedge, drive it back into its mechanism, and then boom, suddenly the door opens. Right? Again, don't do that. Right? Don't use this information in a negative manner or in any way that can get you in trouble, because that's not on me. And so those are crash bars. Right? Even with these right here, the wedge mechanism here, you definitely could probably get a little room up, get enough room that you could get a tool in and then potentially manipulate the wedge. Now, electromagnetic are definitely becoming more common retention mechanisms, solely because a lot of places are relying on some sort of digital access control, so key fobs, RFID, card swipes, some sort of mechanism like that. And so if you're going to go that route, then you might as well use an electromagnetic solution to tie into that, so that you can open it. Now, it's not limited to electromagnetics. You could do door strikes. You could do solenoids. Most commonly, though, it seems that most contractors will install electromagnetic systems. And the way these work, right, is from the exterior in, you have some access control mechanism. So you card swipe, and then you're in. But to maintain securability, but have high usability, they don't want you to have to card swipe out necessarily, depending on your circumstance, right? They don't necessarily want you to have to card swipe out just to leave the building. So instead, they'll add some other mechanism like a push to exit or a motion sensor that when it detects motion near the door, it automatically releases the lock. Or even capacitance sensors. I was in a building for a while where the push bar was capacitance. So when you touched it, it completed the circuit, and then it disengaged the electromagnetic lock so that you can open the door. And then also there are potential issues with power outages. And then the last thing, the magnetron with the question mark. I've never done this. I would love to, but can't find anybody to let me try. Had a buddy who swore to me that you could take a magnetron from a microwave, and if you hold it up on an electromagnetic lock, that basically it produces a greater electromagnetic field that it will offset the EM lock and then allow you to open the door. True or not really sure. I haven't tested it. I would love to. If you know a place or know a busted microwave, I'm in, I'm down, I'm there. But that's just one possibility, right? But with a lot of these mechanisms, right? Exit buttons, motion sensors, capacitance, we come back around to that underdoor tool, where basically if that mechanism is there, it's there, you can see it's there. Well, can you reach it? Right? An underdoor tool, you could potentially reach in and hit a button from the side. Motion detectors, you can get tool. It doesn't have to be an underdoor tool. I'm just using that as an example. You get the tool in, you wave it around such that you trip the motion sensor, door opens. Or in the case of the capacitance touch, and the issue that we had with it was that you could walk in with a coat hanger and just basically reach in, touch the coat hanger to the capacitance bar, and because the metal was conductive, it can obviously made the connection, and the door opens. Of course, there's another fun thing you can do with motion sensors. This was a clip filmed in this hotel, I think 2 years ago, by the illustrious progenitor, Dave. And basically what he's showing here is the door is locked. He's pointing out there's a motion sensor on the top. And then basically, dude, we get it, you vape. So he proceeds to rip off that vape, and he's blowing it through the crack at the top of the door. So he does the first one, puts a cloud in the air, does the second one, and then the cloud, the smoke, the vape, is enough that it trips the motion sensor, and then he's able to open it. And so
last week.
Oh, did DV do it recently?
Yeah, except he do a Scotch or a bourbon.
Yeah, because typically those sensors work off of particulates in the air and basically how you can occlude the ultrasound, the ultrasound frequency that it's emitting. So so just understanding how the mechanism works can then give you ideas on how to bypass it. And that in a nutshell is what this talk was about, right? Your mileage may vary. How you use this, how you see this, will vary for you. Will vary based on your environment, your scenario, what you have going on. But what I'm trying to emphasize here is understand how your barrier, your retention mechanism, whatever that is, understand how that works, because you may think of a way to open that's faster than just sitting there and trying to pick it, or that's not as destructive as just breaking it. Whatever that may be, is bypassing a better option for you. And of course, this GIF again from Reddit. Really nice looking lock, really fantastic looking gate, right? Obviously it's a security gate, and then you can just reach in and manipulate the lock from the side, and the door opens. So with that in mind, comments, questions, concerns, angry outbursts. Yes, that is a shiv at the bottom of angry outbursts.
For bypassing the magnetic locks, I've seen some stuff where they do stick like a really powerful magnet on the outside of it, and I guess just like you said with the magnetron, it overrides it and pulls the lock away or whatever.
Okay, very cool. I've not seen. Yeah, I'm sure. I totally believe that though, especially with some of the rare earth magnets, because EM fields work basically on whichever one is strongest wins, right? So if you have a video of it, I would love to see that actually. Okay, cool, very cool. Well, I'll get it from you in a second if you don't mind. Yeah.
Yeah, I'll think of it.
Oh, really? Interesting. So no, I haven't seen any of those. I'll have to look for that too. Very cool. All right. Well, terrific. Be sure and follow the red shirts out of the room. I think there's a specific way to leave the room. Be kind to your neighbor around you. Don't trample anyone. Again, thank you. Have a wonderful evening. Enjoy your dinner. Good night.
It was like a TV show that lasted like 2 episodes. So
Oh, was it that